Hello and welcome back. Today we'll be doing question 7 from the 2012 STEP paper 3. So, let's get started. A painkilling drug is injected into the bloodstream. It then diffuses into the brain where it is absorbed. The quantities at time t of the drug in the body and the brain respectively are yt and zt. These satisfy y dot equals negative 2 y minus z, and z dot equals negative y dot minus 3z, where the dot denotes differentiation with respect to t. Obtain a second-order differential equation for y and hence derive the solution y equals ae to the negative t plus be to the negative 6t, and z equals half ae to the negative t minus 2be to the negative 6t, where a and b are arbitrary constants. Part 1. Obtain the solution that satisfies z0 equals 0 and y0 equals 5. The quantity of the drug in the brain for this solution is denoted by z1t. Part 2. Obtain the solution that satisfies z0 equals z1 equals c, where c is a given constant. The quantity of the drug in the brain for this solution is denoted by z2t. Part 3. Show that for 0 less than or equal to t less than or equal to 1, z2 of t is equal to the sum from n equals negative infinity to 0 of z1 of t minus n, provided c takes a particular value that you should find. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started on part 0. Firstly, we'll take the left-hand equation, y dot equals negative 2y plus 2z, and rearrange it to give z equals 1/2 y dot plus y. We'll then differentiate this left-hand equation to get y double dot is equal to negative 2y dot plus 2z dot. And this should simplify down to negative 7y dot minus 6y. Therefore, we have that y double dot plus 7y dot plus 6y is equal to 0, and the auxiliary equation is lambda squared plus 7 lambda plus 6 is equal to 0. Solving this gives lambda equals negative 1 or negative 6, and therefore y is equal to ae to the negative t plus be to the negative 6t as required. We can now find y dot, which is equal to negative ae to the negative t minus 6be to the negative 6t, and we can substitute these back for z equals half ae to the negative t minus 2be to the negative 6t as required. Now, let's move on to part 1. Here, we have z0 equals 0 and y0 equals 5. And so, we have a equals 4b and a plus b equals 5, which solves to be b equals 1, a equals 4. Therefore, z1 of t is equal to 2e to the negative t minus 2e to the negative 6t. Similarly, we can solve part 2 by setting z of 0 is equal to c and z of 1 is equal to c, which gives half a minus 2b equals c, and half a multiplied by 1 over e minus 2b multiplied by 1 over e to the 6 is equal to c, and we can solve this set of simultaneous equations. This set of equations is significantly harder to solve. However, this should give a equals 2c e to the 6 minus 1 all over e to the 5 minus 1, and b equals c e to the 5 e minus 1 over 2 e to the 5 minus 1. We can then, of course, write z2 of t is equal to c e to the 6 minus 1 over e to the 5 minus 1 of e to the negative t, take away c e to the 5 e minus 1 over e to the 5 minus 1 of e to the negative 6t. Now we can move on to part 3. Firstly, we'll take the sum and we will expand it in reversing order from n equals 0 all the way down to n equals negative infinity. This should be equal to 2e to the negative t minus 2e to the negative 60 plus 2e to the negative t plus 1 minus 2e to the negative 6t plus 1. And of course, this will increase all the way towards t plus infinity. We can now collect some like terms and do some simplifying, and we'll find that this is equal to 2e to the negative t plus 2e to the negative t e to the negative 1 plus 2e to the negative t e to the negative 2, and so on. Take away 2e to the negative 6t minus 2e to the negative 6t e to the negative 6 minus 2e to the negative 6t e to the negative 12, etc. These terms can be collected, and we'll now notice that these two brackets here are in fact geometric series. We can now use the sum to infinity to say that the sum to the left is equal to 2e to the negative t, e over e minus 1. Take away 2e to the negative 6t, e to the 6 over e to the 6 minus 1. And this is equal to z2 of t when c is equal to 2e over e minus 1 multiplied by e to the 5 minus 1 over e to the 6 minus 1. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.